You should have out Lecture 7 notes. Um, so we've been looking at relative frequency charts and relative frequency histograms, and we've been doing it so far for discrete data. If you go back and look at the couple examples from before, these were all data that you got the values by counting. But we can develop relative frequency charts and relative frequency histograms for continuous data as well. In this case, so we're going to look at relative frequency charts and histograms for continuous data, CTS data. All right, so what is a class in this case? Before, a class, excuse me, was one data value, right? Well, a class is now an interval of possible values. All right, so the whole range of data, the range, and I think I'm going to change my marker because I think this guy's about dead. Let's try yellow. Yeah. The range of data, you remember, for a continuous data set, the range of data is an interval. All right, so a class is really going to be a sub-interval of the interval. So what we'll do is we'll divide the interval up over the range of the whole data. We'll divide it up into equal sub-intervals. All right? In this case, we have the concept of, I guess I'm ready to say, definition. Class width. In my relative frequency chart, the class width will be a sub-interval. I'm sorry, the class will be a sub-interval, and the class width will be the difference between one class's, let's say, left endpoint and the left endpoint of the very next class. All right. If that's a little bit confusing, it'll make a lot more sense if we just do an example. So let's jump to the example here. You read there, at a certain hospital, the weights of 25 newborns were recorded over a given time period, resulting in this data set. We would think of this as a continuous a set of data drawn from where you would get data that's continuous, right? And that from the lowest weight up to the highest, the weight of any given newborn could be anything in between, right? We aren't going to count, we're going to measure what that is. We're going to weigh what a newborn weighs, and that value could be any value in between. Now, we are going down to the nearest tenth of a pound, so we sort of discretize it by doing that, but really the weight could be anything in between. So we certainly have a continuous data set. And it says here the weights vary from about 4 pounds to over 10 pounds. So that's my interval, really. I want to build the relative frequency chart. And my first question is, what should the classes be? And what should the class width be? And this is where, what we're going to be doing is we're going to pick that interval from 4 pounds to somewhere over 10 pounds. Or we're going to chop it up into subintervals. And then we're going to record the data values, the frequencies of the data values in each of those subintervals. And how many subintervals should we pick, and where should we start? What should be our low point? What should be our high point? And all of those questions really are a little bit up for grabs. We just have to kind of think of what makes sense for the problem. So if you go way back, and I think the first lecture I said statistics was the science of extracting information from a set of data. Well, this is where we might say it's a little bit more of an art. We just got to kind of think of what makes sense. If you look through the data set, you see that there is no weight that's below 4 pounds. And so we might start at 4 pounds, and we have to go up to something over 10 pounds. All right, and if I want my number of classes not to be too many, I'm going to just suggest that we make each class width be 1 pound. So let's try try this. So lowest class's left endpoint will be 4 pounds. And since it's to the nearest tenth, we should write it as 4.0 pounds. And let's make the class width be 1 pound, which is 1.0 pounds. Okay, so when I go to draw my relative frequency chart, I will have a column for my classes, and then I'll do my frequencies, and then I'll do my relative frequencies. Okay, so the class is going to be an interval of values. Well, so it's going to start at 4.0 and it's going to go up to some number here. What number goes there? This is where we have to understand very carefully what we mean by class width. It's the difference between one class's left endpoint and the left endpoint of the next class. In other words, since the class width is 1 pound, I go not from 4.0 up to the right endpoint here being 5.0, but instead the next left endpoint will be 5.0 up to something. The next left endpoint will be 6.0 up to something. And let me just stop and figure out what that something is. What I want to do is pick a right endpoint here that captures all the possibilities, but I don't want to pick, you see, I don't want to say 5.0 here, because that will give me everything between 4.0 and 5.0, but what if a weight is actually 5.0 pounds? Would it go in this class or would it go in this one? Because there's also 5.0 here. So what I need to do is just take it out to 4.9. If I take it out to the nearest tenth for the number that's 1/10 less than 5.0, I'm going to cover all possible weights that are between 4, above 4 or equal to 4, but also under 5. Then when I go to the next class, I can start with 5.0 and I'll go to 5.9, 6.0 to 6.9, so then it's going to be 7.0 to 7.9, 8.0 to 8.9, 9.0 to 9.9, and I do need to go above 10, but I don't think I need to go up to 11, so I think I can stop right there. This looks pretty good because I have what? 1, 2, 3, 4, 5, 6. I have 7 classes. That's not so many that, like when I draw my histogram, it'll be so many bars I can't think of what I really have. And it's not so few that I will crunch so much data into just a few intervals, I won't really get a good picture. This is probably a good number of intervals. I could have gone up every half pound, right? I could have 4 here, 4.0 here, and then 4.5 here, and then 5.0. I could have done that, but it probably would have made too many bars and would have been too much of a cluttered histogram. It would have been hard to see the information really clearly. Okay, one more thing. Let me just point out. What if the data down here had been given to the nearest hundredth? Do you see that what I would just simply do then is I would go out here, the right endpoint would be 4.99. The right endpoint here would be 5.99. I just have to go out far enough to make sure I can pick up any data value that I have in my data set, and I just don't want to go all the way up to the right endpoint because I don't want to have to double count data or figure out where to put data between one class and another. I want there to be no ambiguity. Okay, after all that talking, we go through now and look through the data set there, and what I get is between 4.0 and 4.9 there are 3. Between 5.0 and 5.9 there are 3. Between 6.0 and 6.9, you could pause me and see if you get these numbers that I'm getting. I get 6, and then I think I get 6, 4, 2, and 1. All right. So my relative frequency over here is 3 over, the total is 25. All right, so I get 3 over 25, so I get to 0.12. Here is 0.12. This will be 0.24, 0.24, 0.16, 0.08, and 0.04. I usually put 0.12, 0.12, etc., but I don't need to do that. I won't bother to do that here. All right, so let's see. The data is, I guess my notes here tell me to mention, yeah, data is to the nearest tenth. I've already done that. Let's go on to construct a relative frequency histogram. In order to do that, let me see if I'm going to I'll probably do it right here. If I see if I can have enough room, I'm going to try to probably have to scrunch things a little bit. Okay, I know that my first bar starts at, the width starts around 4.0. So I'm going to put a little jag like that and then go out like this. And let's see if I give myself enough room. So this is going to be my classes here. And I'm just going to say it's the weights in pounds. Since we're doing a continuous random variable, or sorry, that's for later. Since we're doing continuous data, we're getting these data values by measurement, so we better give the units, right? Before we were doing discrete and we got the data values by counting, we didn't have to have any units. Well, we should state what our units are. And over here I'll put relative frequency. Okay, now the reason I want to take the time to do this is because there's just a little bit more work that we have to do here. How do I center my bars? Where do I put my bars here? I want a bar that is right above this interval, a bar that's right above this one, et cetera, that has the correct height on it. Well, in order to center it correctly, what we want to do is we want to find the class midpoints. So how do you find the class midpoint? The answer is it's exactly in the middle, the point that's exactly in the middle of each of these intervals. So what I do is I take the left endpoint, I'm going to abbreviate here, left endpoint. Actually, I'm probably going to regret drawing this close to my diagram. We'll see. Left plus the right endpoint of a given class and divide by 2. Okay? So let me do the first one. I get 4.0 plus 4.9 divided by 2, and that's 4.45. All right? How will I get the next one? I'll take 5.0 times plus 5.9 divided by 2, and I will get 5.45. So there's that one, then it's 5.45. The next one, I'll get 6.45, and now here's something you can notice. Once you get the first class midpoint, I can just take the class width and add it to get the next one. Add it to get the next one. So I got 7.45, 8.45, 9.45, and 10.45. Those are the marks I'm going to put on my horizontal axis. And I can tell right now I'm going to probably be a little bit crowded here. But let me put one right here, and that's going to be 4.45. And I'll put one right here, and this will be 5.45. And here is 6.45. Here is 7.45. Here is 8.45. 9.45. Trying to keep these all to be of the same width. Your classes should all have the same class width, right? You don't want to gather data for bigger intervals and smaller intervals. You get you get a confusing picture that way. Okay, now what do I want to have? I want to have my bars touching, and I want them all to have the correct height here. And I think if I make this be 0.04, let me just go up, this will be 0.08, 0.12, 0.16, 0.20, and 0.24. That's the highest we have to go. Okay, so I am going to go for the class midpoint now. That will represent this class. The 4.45 will represent all the data values in this class, so I go up to 0.12. And how do I do that? Well, the bars are going to touch, so the right side here, the bar will be right between 4.45 and 5.45. So I'll go up to 0.12, and I'll go across, and I want to come over this way the same amount. Actually, a little bit narrow. It should be a little bit, can I fix that? Yeah. Should be a little bit wider and come down like that. Okay, the next one is also has height 0.12, so I come over here and go down to about right there. The next one, The midpoint 6.45, that's for this subinterval. So I have a frequency of 6, or a relative frequency of 0.24, so I take it all the way up to 0.24. And actually the next two are like that, so let me go too wide, just to make my drawing a little easier, and then do a line down the middle like that. How's that? Not bad. For this one, I want to go up to 0.16, so I go up, start there, and I go to there. All right, and then for this subinterval, I'm using 9.45, and I go up to 0.08, so I go up to right there. And then lastly, for 10.45, for the class that has that as its midpoint, I go right there. So what I have then is I've taken kind of a representative value for each of the values in a given subinterval, and that in a given class, and that is I've taken the midpoint, and I've centered the bars over the midpoint. All right, so I guess I want to say here a class boundary. I got room here to put this in, I guess. Class boundary. That's halfway point. That's the halfway point between, I'm going to abbreviate as much as I can here, between a right endpoint of one class and the next class's left endpoint. So the next left endpoint. Okay, so look here. I have the right endpoint of the first class is 4.9. The left endpoint of the next one is 5.0. So I have 4.9. Halfway between there, I will get by adding up and dividing by 2, right? And of course, that gives me 4.95. Okay? Well, now I can just add the class width and get all the other class boundaries. So I get 5.95, etc., all the way up to, 9.95, and actually there's one there. There's 10.95. And there's even one, then what I'm doing is I'm figuring out the sides of my bars, right? The exact halfway points here. So the one that extends over here is 10.95, and the one that extends back here is actually 3.95, right? So there's actually 3.95. And you could see, we could put all these in, right? I'm not going to put them in because the diagram gets way too crowded, okay? But I could label all those in, and that's how we know where the bars touch. But really, you get the midpoints drawn, and you draw the bars so they touch, and that kind of just takes care of itself. You don't need to do all that work. Few things I want you to notice. Note. As before, like I said, the bars touch. All right. Each bar centered over, let's see, I got to be careful. I think I might have gone off. Yeah. Shucks, my marks are gone here. Yeah, my marks are, and I can see I've gone off a little. I apologize. My marks are gone. I had marks here that tell me where to go, and now I see that they're gone. So I hope you can read what I've done so far. I'll be a little bit more careful, though. Each bar centered over the class's midpoint. Now, the probability, the empirical probability, does not equal area necessarily. And this is because my class widths now could be of any size. Here there's 1.0 pound, but I mean 1.0 pounds. I could have picked them to be half pound or 2 pounds or whatever. Then the height gives us empirical probability, but I wouldn't necessarily be multiplying by a width of 1, so the area wouldn't necessarily do that. We'll take care of that sort of a situation later. The other thing I want to notice is that the graph has a rough bell shape to it, all right? And you can kind of see, if I just draw kind of an envelope here, I get kind of a bell shape. and that should maybe ring a bell with you, haha. We will see that this comes up often when we look at data sets, and it will have some deep significance later on. I just kind of want to point it out right now. All right, got a couple empirical probability questions for you. The thing to understand, though, is I'm not going to ask what's the probability that a data value will equal a certain value. In a continuous data set, we don't ask questions like that. We ask a question like, what's the probability that a data value will be in some particular interval, say in a particular class, all right? Not just that it equals a particular value, but that it's within two values. All right, so in some class. So let's see. So let's try this. Find the empirical probability a newborn chosen at random weighs. I'm not going off, am I? No, I think I'm okay. Weighs between 6.0 and 6.9 pounds. Okay, and right here, number 2, things are getting awfully crowded. How about, I'm just going to abbreviate here. I want it to be between 5.0 and 7.9 pounds. Okay, so pause and see if you can do that, and then I will come back and do them. Okay, this should be very easy. Between 6.0 and 6.9 pounds, that is this class, right? And I can look right here and see that it's 0.24. I can look at my height and see that it's 0.24. That's 0.24. What about between 5.0 and 7.9 pounds? That corresponds to this, and this class, doesn't it? Those 3 classes. So it corresponds to this, and that, right? And if I add those up, I get 0.12 plus 0.12 plus one of them, that's 0.24 plus I'm going off the screen down below, I think. Doggone it. 0.24. So if you can hear my voice, the answer turns out to be 0.6, right? 60%. And I'm going to have to redraw my boundaries here so that I don't go off. Somebody erased them all. But I hope that's good enough. We'll stop here.